this video, we'll be going over some fractions. It looks like we're subtracting fractions today with some mixed numbers in them and whatnot. This class is for, this worksheet is for the class Hands-on Fun with Rational Numbers. If you're not in this class but would love to learn these skills, please look down in the description and you can follow the link. If you're one of my students, I'm about ready to pause and then you can grade your work. So there are the answers. Now for this worksheet, I'm going to be solving it using the improper method of adding and subtracting. If you do the vertical method for your math, all you have to do is pick the other video for this particular worksheet. I usually make 2 videos for my adding and subtracting worksheets with fractions for all of my classes because I don't want to change the method you've already started being introduced to fractions with. I just want to add on to your method. So I always make 2 different videos, one for either method at this point. Okay, so go ahead and grade those, grade your worksheet, and I'm going to get started, so please pause if you haven't finished. All right, in this first one, our denominators are the same, so I don't have to worry about the denominators at all. They're both 8s. So because they're 8s, remember this is sort of like a place value. So the place value of these 2 fractions are 8. And just like when we would add decimals, we didn't change the place value. We didn't put the answer in a different place value. We kept it in the tens place or the hundredths place or any of those places. And we're going to do the same here. We're going to bring over the 8, which is our place value. And we're just going to subtract the top 2 numbers. We're going to subtract 4 from 7 and get 3. All right. And we're going to do that for the second one. 3 is our place value. It just comes over. Subtract 1 from 2 and get 1. And again, for the third one, we should already know how to do this. The place value is 14. Take 3 away from 7 and get 4. All right. But then things get a little weary because we have to come up with common denominators. Remember, this is the number that both of them go into, and you don't have to find the smallest number, the least common denominator, okay? I don't care about that. Does it make your math a little cleaner? Yes. But it's still right if I use bigger ones, you know, ones that are bigger than the smallest. So I'm not, don't get all caught up on finding the smallest. That's my point. All right, in this one, I'm going to actually do different ones, okay? Because this, I should have reduced this to 1/2. So if you did, good job. I slipped up there. All right, so the answer is actually 1/2. We should be reducing by this worksheet. What I'm going to do, and I purposely for these 3, when I did my answer key, showed you what I found as my common denominator on purpose, okay? Because this time I'm going to erase all that, and I'm going to use a different common denominator to show you if you just multiply the bottoms, you're going to get the same answer. Is there a little more work involved? Yes. But don't stress out over this one little skill. All right, so I'm going to erase what I did here. So if you're looking at your paper and you're like, I didn't get those common denominators, that is all right. What I'm actually going to do for this one is I usually teach a when in doubt method, which is when in doubt, when you don't know what the answer is, multiply the denominators together. So in this case, it'd be 6 times 3, which is 18. Okay? And that's not the denominator I used last time, but that's okay. That's okay. I'm going to show you how I'm going to get the same answer. So that means I multiply both top and bottom over here by 3, because 3 times 6 will give me 18, and over here by 6. That's going to make my new numerators 15 and 6. So 6 take away from 15 is 9. 18s are around. Now I have 2 different ways of reducing this. I can either say both top and bottom are divisible by 9, Or I could say 9 is half of 18, therefore I know it's an equivalent fraction of 1/2. Either way will get you to the answer of 1/2. So see, it doesn't matter if I pick the smallest denominator possible, I just have to pick one, okay? I have to pick a usable one. All right. So before I use the common denominator of 45, this time I'm going to multiply my two together. It's going to give me a really big one. 10, 11, 12, 13, yeah. 135. All right, which means I have to multiply top and bottom by 15 over here and by a 9 over here. So 15 times 8 and 7 times 9. All right, so I need to take 63 away from 120, which is going to be 57. I'm going to double check that because for some reason that does not sound right. Nope, it is. I need to have confidence in myself, don't I? Okay, so now here's the reducing. I have to reduce this. So I got to think of what are the common factors of 57, and it's always easiest to start with 2 and 3. So obviously 2 cannot go into this because it's not even, but 3 can go into it. I know that 3 can go into it because if I add the digits together, 5 and 7, I get 12, and 3 can go into 12. And it can go in, 3 can go into 57 19 times. 3 can go into 135 how many times? Let's see. 3 times. So I know that 3 can go into both. 3 can go into 57 19 times. 3 can go into 135 45 times. So that is my answer. I get the same thing. Look, it might be a couple extra steps, but it's not wrong. All right. So that last one, let's go ahead and multiply the 6 and the 9, and it's going to be 54. So that means I times both the top by 9, and I times the bottom, or the top and the bottom by 6 over here. Because 9 times 6 gives me 54, 9 times 5 gives me 45, 9 times 6 gives me the 54, and 6 times 7 gives me 42. If I subtract these, I get a 3 over 54. When we know full well 3 goes into 54, okay, it goes in 1, 8, 18 times, and into 3 one time. All right. So different denominator still works. Okay, this next group has some whole numbers in it, and the very first one is a complete whole number. It's not a mixed number, it's just complete whole number. All right, so I just have to throw a 1 underneath it. And the reason this works is because if I divide 1 into 8, I still get 8. So I'm not changing the number. I'm just making it a fraction so that it's easier to do this. Now there's two different ways to look at this. If you do the vertical method, you stand here and say, oh, that's 7 1/4. How did I get to that? I have 8 cookies. Someone came along and took 3 bites, leaving me taking 3/4 away from my cookie. Well, I have 7 full cookies and 1/4 left over. We do the complement method. We can still do that with this method. We just have to find a common denominator. And so we don't have to look at it that way. But if you're like intrigued by the way I did that in my head so fast, watch the other method. Watch the vertical method and see if it clicks. So if I multiply 1 and 4, I get 4. So I know my common denominator is 4. That means 3/4 gets to stay the way it is. But this one I have to multiply by 4, which means my top is 32. If I take 3 away from 32, I get 29 over 4. Now I got to turn this back into a mixed number. 4 goes into 29 6 times. Oh, 7 times. Sorry. Because 4 times 7 is 28, which will leave me with 1 extra over 4. So 7 and 1/4. Still got the same answer, just a different method. All right, so this is the improper method video. So I'm going to turn these into improper fractions first, which means taking my 8 bags of cookies that each have 4 cookies inside, dumping them out on the table and adding them to my 3 leftover cookies, which is going to give me 32, 35. This next one is going to be 8 times 5, which is 40, plus 7 more, which is 47 over 8. For a brief second, it looks like we can't do this because 47 is bigger than 35, but I still got to find a common denominator. Now we're going to do it the method where we multiply, and my common denominator is a 32. It means timing this by 8, timing this by 4. So now I have 32 over 8 times 35. $280 minus 4 times 47 on the top is 188. That's a lot better. That makes more sense in my mind. And now I can subtract my numerators. And I get a 92. Last step, I got to turn that into a mixed number, which means dividing top and bottom. And I get 2 whole, okay? Because 32 times 2 is 64, all right? And 92 minus 64 will give me a remainder of 28. Now this can be reduced, right? 4 can go into both. 4 can go into 28 7 times and into 32 8 times. Gotta fit that 2 in front. 2 and 7/38. All right, for this one, first I gotta turn them into improper fractions. So that's multiply, that's 42 plus 3 more is 45 over 7. This is multiply, 6 plus 2 more is 8. All right, my common denominator, if I multiply them together, is 21. All right, and I'm going to multiply 3's over here and 7's over here to do that. So 3 45's are going to be 135. And 7 times 8 is going to be 56. Which is going to give me an answer of 79 over 21. Now we have to divide these. All right, I'm going to guess this goes in about 3 times, which leaves me with a remainder of 16. So the answer is 16 over 21. These two do not share multiples. This one is a multiple of 4 and this one's a multiple of 3. So we can't reduce that anymore. All right, we're getting close to the end on this one. First, we turn them into improper fractions. 21 over 4 minus 3 over 2. Multiply the denominators. Remember this video I'm doing where you get different ones than the ones that I've gotten on the answer key. All right, so I'm going to multiply this side by a 2, this side by a 4, and my new fractions are 42 and 12. If I subtract, that's going to give me 30 over 8. 8 can go into 30 3 times with 3 times 8 is 24, so that would give me 6 left over 8. Both of these are divisible by 2, so let's go ahead and reduce them. And that's going to be 3 over 4. Let's make our mixed numbers. We should know how to do this by now. That's why I'm going so fast. But if you need a refresher, let me know. I have a video on how to do this on my YouTube channel. All right, I'm going to multiply, and that's going to give me 6. 6, 6, 38, and 15. If I subtract that from that, I get 23 over 6. 6 can go into 23. See, 3 is 18, and I think that's the highest. So 3 and 5 left over 6. All right. So you see, it doesn't matter. It does not matter. We can always reduce it at the end. All right. Don't get hung up on trying to get the least common denominator when any will do. All right. This is going to give me 16 if I multiply them together. And that is going to give me 86. And over here it's going to give me 40, which is going to give me 46 over 16. All right, how many times can 16 go into that? Well, I'm going to guess 2 because that's 32, which leaves me with 14 left over 16. I can reduce this by 2. I know that because they're even. If they're even, they have to be a multiple of 2. All right, which gives me 14 over 8, and the full answer is 2 7/8. All right, so by now we should be able to do these problems. I'm going to do it real quick, and then I'm going to write my steps as I go. All right, and this is going to vary, okay? Answers will vary, but I want you to have the same general idea. So in your your type of method, we're doing the improper method. So the first step is to change mixed fractions to improper fractions. All right. I'm going to do the least common multiple this time. So the next step is find common denominators. All right, in this case, we're going to do 16 because if I times 4 by 4, I get 16. And then I have less work for myself because I don't have to do that other one. But if you multiply them together, not going to change anything. I just want to show you this other way too. If I multiply the bottom by 4, I have to multiply that top by 4, and that is going to give me 108. So if I take 108 and subtract the 64, because now I have common denominators, so I just have to subtract across the top, I get 45 over 16. So how many times can 16 go into 45? Well, it can go in twice, because 16 times 2 is 32, which leaves me with, you got to take 45 and subtract 32. It left my brain what I was trying to say. And that leaves me 13 left over, and it's out of 16. So 2 and 13/16. All right, so I forgot some steps. Find common denominator, change numerators. And I'm going to put in here, make equivalent fractions. That's the super mathy way. And the last step is to subtract numerators, keep denominator. So just have something written down or modeled um, that kind of says that. All right, so that's it for this worksheet. Let me know if you have any questions, and I'll see you in the classroom.